Good morning, everyone. Today's topic is about Python internals, and we'll look into how Python stores all the values that we have been giving to it, all the different type of variable values. How are they stored in case of Python? So this is what we will study. For starting, let us just consider any memory allocation, be it in case of any programming language. So just consider for part-time, consider that a memory is like an empty book. So when you consider this, assume that there are multiple people who wish to write into this book. So what may happen over this period is you will have to devote a person who is going to monitor who will write where. Suppose 5 of you are there. We name you A, B, C, D, E. So you will be given spaces. Okay, A, this is your time. From 1 p.m. to 2 p.m. this book is yours. Write from page number 1 to 10. Then B will be given time from, say, suppose 3 p.m. to 5 p.m. Now B, it is your time. Write down from page number 21 to page number 35. Okay, whatever you wish to write, you will be given spaces, and that book manager who is giving you the space needs to ensure that by the time it reaches E, he is not out of the pages of the book. So it should not happen that the book is of very small size and you have given spaces, very large spaces to people to write it down. Okay, so all these things needs to be ensured. When you compare this with actual programming, you may find that any book may be compared to a memory in particular cases with any programming languages. Then all the authors or writers into the book may be considered as different users or different programs which want to take space in the memory when they are executing. The book manager who is managing how particular space should be given should be compared with, what should I say? He should be compared with the memory allocator that is there in Python. And finally, what may happen is, suppose you have written something like, for now, after 5 months, just for example, in case of a book, after 5 months, that particular page which you have written over there is of no use or is no longer read by anyone, or no one is referencing that page. So what may the book manager do? The book manager can erase whatever you have written, and then he can render that page or he can give that page to some new writer. The reason, he does not want his book to be full entirely, or neither does he want that some unused pages are still hanging around there. So this concept of erasing and re-giving the space to someone is called as garbage collection in case of programming language. What happens is, whenever you are using a program or writing a program, you are occupying memory. But as soon as your program is over, you do not need that memory space. What will happen to that memory space? Now, the Python will observe that, is this space still being used by anyone? If yes, let it be. Don't disturb that space. Someone may be referencing it, so they may need values from there. If no program or no variable is referencing a memory location, then in that case, you can easily empty that space. You can mark it as unallocated, and then you can clear that space and give it to a new program which is requesting some memory space. Let us see what we have just talked. So we have talked the very same thing. Compare any book with any empty book with a computer memory. Eventually, the different authors will come along. Each author will want some space to write their story into the book. Before they begin writing, they will consult the manager of the book. The manager then decides where in the book they are allowed to write. And then, since this book is around for a long period of time, many of the stories in the book are no longer relevant. When no one reads the or references the story, they are removed to make room for new stories. So we have talked the very same thing for now. Okay, this is how memory is allocated in case of computers. Python memory management. So let us first talk about something like language C, because we have talked that Python internals have been written in C. So we will first talk about C. It is very difficult to assume that a programming language has been written in another programming language. Okay, so C is the backbone of Python, but it is very different from C, because C is not an object-oriented programming language. When you move ahead in life and when you study programming more or anywhere, then you will come to a concept of object-oriented programming. C is not a language which moves with objects and its concepts. C is a procedural programming language, but Python is an object-oriented programming language. So there is a lot of coding that was involved to ensure that although we are writing this language in C, but the outcome that we get is not a particular language like uh, which is not object-oriented. It should be an object-oriented programming language. Okay, so what happens in C, coming back to the topic, when we assign a variable in C, we first declare it. Okay, so when I have written var1 is equal to 10, it is a bit incorrect. We will be writing int var1 is equal to 10. We will have to write what data type it is. In Python, we do not suggest the data type. We can give any value to any variable. There's no problem, because Python supports dynamic programming. Okay, or but it is not the case with languages like C. You will have to first tell what data type it is. When you first declare the variable, then they will be reserving the space in memory. Something like this. You will be reserving some space in memory. I'm not complicating it by writing the memory address. You can assume that there is any random memory address present over here. Okay, any random memory address is there on which this variable 10 has been stored. Suppose then you declare another variable with the very same value. I have declared one more variable named var2 with the same value as 10. So what will happen in language like C? In C, we'll see that, it is a bit of alliteration, that in the language, programming language C, you will observe that var2 will be pointing to a new memory location. Okay, it will not be pointing to the same memory location as was the case with var1. It will be pointing to a new memory location. And if var2 is given a new value, the same value will be changed over here. Say suppose var2 has been changed to var2 is equal to 20. So the value will be changed over here. Okay, no new memory spaces will be created. What happens in case of Python? In Python, which has been coded in C, instead of storing values in the memory space reserved by the variables. So what was happening in C? We were storing the values in the memory space which were reserved for variables. So what happened in case of C was, we were just hang on. Nivedita, just will you mind taking the attendance and putting it up for yourself? I will ask you at the end. Please ensure that you are taking the attendance.
Yes, sir.
Just note down the names of the students who have joined.
Yes, sir.
Thank you. So see, when it comes to Python, Python has the variable refer the value. It is not, so values are already present over there in Python. See, for an example, you already have some preset values there stored in Python. What used to happen in C? In C, we were first creating the variable and they were given some spaces, and then the value was being stored in that space. Okay. Here in Python, we have some spaces already allocated for the values. Now, when you create a variable by writing var1 is equal to 10, var1 will not be given a new memory space. Rather, var1 will be uh, pointing to the memory location where the value is stored. So it will see, okay, 10 is stored over there. So var1 will now be referencing that memory location. Okay, 10 is over there. I am pointing to this value 10. When there is another variable named var2, again, no new memory space will be given to it. Rather, it will be pointing to the value 10. So by this method, memory optimization is being done in case of Python. You have optimized the use of memory over here. You have also ensured that you are not wasting memory by any measure. Okay. So there we say in general that each time we create an object or each time we create a variable that refers to an object, a new object is created. Okay. In case of, this is in case for all the objects that we are talking about. So what are objects? Say suppose any value that you are giving 10, 11, 12 in the previous case, for an example, these were objects and these are my variables. var1, var2 are my variables, and 10, 11, 12, the value that I have been giving to them are objects. So now read this line. Each time we create a variable that refers to an object, a new object is created. Okay. For example, let us talk about the mutable object list. So when you talk about list, so suppose we all know that lists are mutable objects. Why do we call them mutable object? Because uh, you can changes are allowed for uh, the values that are stored in a list. So suppose you have a list 1 to 3, you can add a new value, you can delete a value from here. But such was not the case with tuples. Okay. So lists are called as mutable objects. So suppose var1, you have given a list 1, 2, 3. So what will happen? var1 will now be pointing to a list 1, 2, 3. You have created another variable var2 with the same value 1, 2, 3. Okay. What will now happen? var2 will be pointing to a new object. Read this line again. Each time we create a variable, we have created variable var1, we have created variable var2, that refers to an object. Both of them are referring to a value, which are objects. A new object is created. A new object is created means a new memory space is reserved. Okay. So this is in complete contradiction with what we just saw. We saw that variables will be pointing to the same value. Okay. So this is in complete contradiction to what we just saw, that Python supports sharing of value. So it is not all the time that Python will support sharing of values like the one which we saw over here. It is not all the times. It is for just few values. So let us see what are those few values. Before that, we will do another example of this. Say suppose I wish that still with list, whenever I'm creating a list, I want them to point to the same values. So what I can do that through aliasing. How can I do that? Var1 is given a value 1, 2, 3. And now I will alias this object. Remember, aliasing is I'm not creating a new object. I am just giving this object a new name. So suppose one of you is named Virat one of you is named Virat. Your formal name is Virat, but then there is Chiku, another name of yours. Priyanshu will relate very well to this. Okay. So var2 is equal to var1. Now var2 will be pointing to the same object. If there are any changes over here, the same changes will be reflected when you print either of the two values, be it var1 or be it var2. Okay. So remember this point. You can do it through aliasing, but it is not always going to happen. Python memory management. Okay. See, whatever we just talked, we have done an example for this. So we created a list L1. We stored memory 1, 2, 3 in it. We created another list L2 and we stored value 1, 2, 3 in it. So L1 equals to L2. You can see that these are two different objects, but them values are same. So this will give true because the double equals to operator will check for equality of values. Okay, 1 is there, 2 is there, 3 is there, same order. Okay, well and good. Then when it comes to L1 is L2, are the memory spaces same? No, they are not. You can check their memory numbers with the help of the ID function. If you remember, there was a method or function named ID through which you can check what values or what is the memory location for a particular object. So you can check it through the ID method. So the ID method will show you there are different values. So L1 is L2 will give you false. The reason is both the objects have been stored at two different memory locations. The same thing that we studied 2 slides back. When we do something like this, now we are doing an aliasing over here. See, we created two different objects over here, but rather when we are writing L1 equals to L3, sorry, L3 equals to L1, then over here I have created an alias of L1 in L3. Comparing these two, because both the memory locations are same, we will get true because both of them are pointing to the same memory location. L1 is L3 and L1 equals to L3 because they are having same value, and moreover they are aliases of the same object. They both will give you true. Now memory optimization in case of Python. So while it is true that the new objects are created every time, we have a variable that makes reference to it. Okay. So whenever we have a variable make reference to an object, a new object is created, but there are a few exceptions. So what are those exceptions? We will study it right now. There are some strings. What strings are there? How many strings are there? The rule is a bit fuzzy. I can give you a baseline, but the top line is not correctly defined. Okay, the baseline is that if you have single character strings, then or you have strings without any space, then they will be pointing to the same memory location. Okay, let us see the example of strings first. So for an example, let us see that A has a value Python is cool. Okay, B has another value Python is cool. When you are taking these two, in case I am doing this is in the interactive mode. Okay, we are not doing this in the script mode. We are doing this in the interactive mode, and moreover, we are doing it in Python. Ideally, Spider may give you a different result over here. because each of them have a different way of taking on the interpreter. So when you are doing this in Python uh, interactive mode, then Python is cool is one string. This string has some spaces, the point that needs to be noted. B is another string which is having the very same value. Python is cool, no differences. Okay, when we do A is B, it will give me false. Okay, when you do just write Python, say suppose you just write QWERTY, QWERTY. What does QWERTY symbolizes? Where do we hear this word QWERTY? Anyone?
It's a type of keyboard that we
Very
use.
good. Very good. The key placings that we have in keyboards, okay, they are QWERTY keyboards, QWERTY, and B is another QWERTY. So when we do print A is B, see it? Here the strings were same. Here also the strings are same. The difference is that they do not have a space. We have not given any space over here. So what may happen is A is B. When you do it, this will give you true. I tried for a longer version. Okay, I thought that this may be a small string. So I tried a string which is long enough without a space. So even on doing this, it will give you true. The basic rule is if you are trying to do it with any single character, it will give you true. For example, if we are doing it for A is equal to single quotes, double quotes A, both of them have the same value. So A is B will give you true. Again, over here, when you do this, because you are providing it from here only, this will again give you true, A space B. But if you are taking the same as an input from the user, let me just write A over here and let me just write A space B. Okay, so that I will remember how to compare these. And now I have C. Take a look at the program. We have taken two variables. Both have been given the same objects. Okay. Again, we have taken two variables. Both have been given the same objects. Now, E is asking the user to enter a string value, and then it is compared if the string value that has been entered. So we will be entering A over here, only A. So that particular value will be compared with the value that has that particular value memory address will be compared, that are they both pointing to the same object. So that comparison will be done over here, and over here we will be comparing with A space B. So C and E will be compared. So E first will have string A, and then E will have a new string A space B. So you can see both of these are pointing to the same memory location. Therefore, it is giving me true over here. And also these are also pointing to the same memory location, although they are having space, but because we have hard coded them in the program, so they will be given the same memory location. But suppose now I'm taking the value of input from the user, and I'm supposed to take A as an input. So I've given A, just A, and I hit enter, then I will get the result true. Now, if I give A space B, this will give me false. The basic motto of making you understand over here is your string may be as small as it may be, but if you have given some longer strings, longer than one word, which has some spaces, then it will not give give it to this or compare it with any object that is already present, it will consider that as a sentence and it will not store it in the same memory location. Rather, if it is just one character or even one word, long word, then it will compare with the values that are already stored in your memory and it will point to the same memory location. I hope you are getting this point. The next example that we have, this particular thing that we have just seen is called as string interning. See this QWERTY and this thing, this is called as string interning. interning, string. This is called as string interning. These two examples are of string interning. The next point over here is integer between the range of -5 and 256 inclusive will be stored or will be stored as the same object. Let us see what, let me just tell you what I wish to convey. Suppose I have 300 stored over here and 300 stored over here. C is a number. A is C. And now when I do, so there is a certain list of numbers from -5 to 256. Remember the range, -5 to 256, where Python, when loading itself, will store the value in the memory. Okay, they will be already stored in the memory. The numbers from -5 to 256 will already be stored into the memory when the program is being loaded. Okay, so because they are stored in memory, so even if you give a new value as an output, even if you take a new value from the user as an input, and if it is within the range of -5 to 256, it will not be given a new value or new space in the memory. Rather, the variable will be pointing to the same object. Okay, let me just show you this with the help of an example. So what have we done? We have actually taken two variables A and B. Both have the value 300. When you compare this, this will give you true, because Python, when loading the program, will already know, okay, A and B both have same value. Why should I give them two different memory spaces? It will, when it is loading the program, it will already give them the same memory space, and both the objects will be pointing to the same memory location. As a result, A is B will give you true. But when you take 300 from the user as an input, this will give you false over here. When you do the same thing for the value 256, A is C is bound to give you true. Let us see this. Oh, my bad. See, the first one was true because A and B were both having the value 300. Now I'm giving 300 over here and this gives me false. Now again it is true for 256, but suppose when I enter the number 256, what will happen? It will give me true. Notice this. So for the number range -5 to 256, you will always have this memory optimization in Python. The same is true for empty immutable containers such as tuple. So if you have an empty tuple, this will be the same thing that will happen, and the same will happen for Boolean true and false. Okay, true and false, if any, by any means, if you are taking input from the user by any means, if true and false are values which will be given given as an input from the user, they will always, any variable pointing to them will be pointing to the same object. They will not be pointing to different objects. So this is it from the concept of Python internals. Anything that you wish to ask, you can do it by rejoining the session. Okay, so I will be ending this right now. I will restart the session because we don't have enough time. If you have any doubts, please rejoin. If you don't have any doubts, then you can please leave. Just let me take attendance of yours.
Sir, I have